Good afternoon, everyone. So I'm from the Red Cross Red Crescent, as was already said, and you all have Red Cross or Red Crescents in your countries. And you probably know us as either the folks responding to disasters or the folks who are chasing you for your blood. But we also do a lot of work on reducing disaster risk, adapting to climate change, as well as a host of other things that I'm not going to talk about today. So the center that I work for, which is the Climate Center, is basically a technical resource for all of those Red Cross and Red Crescent societies to help provide expert advice on how they can then adapt in communities at a local level or partner with Met agencies in strengthening early warning systems, et cetera. And then we are also part of this World Weather Attribution because it supports our mission to sort of reduce the impacts of climate change for the world's most vulnerable. So in WWA, we have 2 to 3 key roles. One of them is the triggering of possible events. And so the way we do that is we have a protocol that got mentioned briefly. This is the full one. You can't read it. It's too small. I've zoomed in on a couple of them. Our actual full list covers not only storms, which includes floods, et cetera, droughts, as well as heat, which is one of the ones on the other one you couldn't see, and wildfires. So this is just to give you an example for floods. WWA is specifically looking for like the most extreme of the extremes, and we do that from an impact-based definition. So we will trigger a possible event for study if there have been more than 100 deaths, if more than 1 million people have been affected, if there's a state of emergency declared, or if more than 50% of the population has been affected. And so that's to sort of cater for different size populations. You might have some smaller countries where some of these might be a bit too high. And we look at these routinely to try and tweak them a little bit and adjust them so that we're getting a good geographic balance. You can see similarly for drought, we've got basically larger numbers, more than 2 million people affected because those tend to be larger events, et cetera, for the different triggers there. So when we get this list, we are usually triggering somewhere between 3 and 5 events every week. We're not studying that many. We can't possibly study that many. So then there's a conversation among the whole attribution team to decide which ones are we actually going to take into a full attribution study. And there's a few factors that we consider there. One of the really obvious ones is, do we have the right information to even be able to study? Although we have made an exception once or twice where the study was so important that we kind of did it even though there wasn't enough climate information. The recent DRC Rwanda floods was an example of that, where we relied more on the vulnerability and exposure components that I'm going to talk about in a bit. But anyway, we decide which ones we're going to study based on the information we have available, trying to bring in local partners, and also trying to keep a bit of that geographic balance so we're not excessively studying one country or region over the other, as well as a bit of a hazard balance. And that's a decision that's made by the whole partnership. It then goes into a bunch of the pieces that Miriam already explained. And the piece that the Red Cross Red Crescent leads on after that is something called the vulnerability and exposure analysis. Some of you may be familiar with those terms, but just in case. Exposure is basically looking at, what people, assets, et cetera, were in the path of whatever hazard that was. And the vulnerability is looking at, are there characteristics that are making people more likely to be impacted or infrastructure more likely to be impacted? So we look at this and do an analysis of this, and it also includes long-term drivers that may have led to increasing vulnerability, for example, or increasing exposure. And we also look at what decisions or actions may have actually decreased that risk. The section that we're working on when we're building out this picture is not intending to then quantify. The quantification of how an event might have been influenced by climate change is strictly on the hazard side. But the reason we're doing this is to try and put it into a bigger picture, because a hazard doesn't automatically become a disaster. It becomes a disaster when it collides with vulnerability and exposure. And we can reduce those impacts by reducing vulnerability and exposure. So this is really important to us because it gives us a better analysis. So when I say now us, the Red Cross Red Crescent, it gives us a better analysis of what was the full picture of how that event came to have 100 deaths or impact more than 1 million people. And this can help us not only think about the recovery context of that event, but it can also help us think about this type of analysis, even in the events that are not being triggered by WWA when we're doing more of our long-term adaptation work or risk reduction work, et cetera. So what I'll do is give a couple of examples briefly. And this is such a small screen, don't worry about reading the text. The purpose of this example is just to say sort of like, what does a Red Cross Red Crescent person see in these analysis once you get to the end? So I'm taking an old one, and then I have a couple of newer ones. So the Hurricane Harvey one I personally find very interesting, which is why I went that far back in time. So here are some things that were interesting about that one. First of all, you can see when the analysis was done on the hazard side, we came to this consensus that it was about 3 times more likely than it would have been in a world without climate change. What is also really interesting, though, is that when we quantify the return time of that event, we see that it's around a 1 in 9,000 year event. So from a Red Cross Red Crescent perspective, or anybody's perspective really, that is exceedingly rare. Even though it's more than 3 times likely, that now that it is 1 in 9,000 years, it's still, like, even in today's climate, extremely rare. So it has interesting implications. You don't necessarily build back for a 1 in 9,000 year event. Maybe some countries do, but for the most part, that's considered like over-investing, right? What was interesting about this event, though, and some of you may know this context even better than I do, because I'm from the US, but not this part of the US, there were many hurricanes and heavy storms that happened prior to this event that were much more frequent return times, not as intense, but still intense enough that they caused lots of flooding. So it can create an interesting planning perspective that even if you may not be wanting to plan to a 1 in 9,000 year event, you can still have that recovery perspective from a disaster take you from where you are to maybe being able to prevent flooding of these events, even if you're not preventing the one that's on this time scale would be way over there because it's 1 in 9,000 years. The other interesting thing about this event was actually the regional component of this. So we kind of looked at not only what was in Houston itself, but what did it mean for the Gulf Coast? And that was more interesting because the odds had also roughly tripled, but then it had become, as of 2017, a 1 in 100 year event for the whole region. And that becomes really interesting because now you're thinking about, okay, from a catastrophic risk planning, it's not actually so rare that this could happen somewhere else and be quite as just as impactful. And obviously these odds will continue to increase. In this case, it was also triple again if we reach our 2 degree centigrade Paris Agreement target. And now you're talking like once every 30 years on average in the Gulf Coast region, a huge event like this could happen. This makes really, really interesting planning inputs to think about where we're headed in the future from a disaster management lens, for example. And then you add that into the context of growing population, urban planning policies, et cetera. 2 others that I'll go even faster through, because they have similar concepts, and that one was a bit more in depth. So you have the Cape Town drought, for example. Coincidentally, also 3 times more likely was the headline message there. Now expected to be roughly once in over 100 years. This is maybe more interesting because you could say hypothetically it went from an event that maybe a water management infrastructure, maybe it was okay for it not to be prepared for if it was 1 in over 300 years that you would get in a drought like this. And if you remember this event, this is where there was the day 0, the city was going to run out of water. And now you're talking about it being a 1 in 100 year event, it's going to keep increasing. Well, now this has huge implications for your water management infrastructure for a city, and how do you really bring it forward in a time of climate change to try and reduce the risk of the city running out of water. And you can see in this one also many other risk factors around the water supply system, rapid population growth. It also had an interesting case of the water distribution system wasn't necessarily reaching everybody equally even before the drought occurred, and this gets exacerbated by the event. And then to give one final quick example, the heat wave, which was just from this past year, and actually the one that Miriam was also talking about, more than 30 times more likely, about 30 times more likely, which is a huge number. And what's interesting about these types of events, as you all know, it's a very different type of disaster, right? They're actually very deadly because people tend to not think of heat as being a risk. And then when it leaves, you don't necessarily have the ability to rebuild. Nothing has actually, for the most part, been destroyed. Maybe some roads got a little warped or something, but for the most part, you have to think about how do you actually reduce this risk by retrofitting into your existing infrastructure. And you're talking about these huge, huge increases that we know are coming. I mean, you can see from the IPCC that these big risks are coming, but this helps to really quantify it and make it more tangible and real today. So I'll just end here with basically on that final point of like, why does the Red Cross really care about this attribution work? And it is the public education component of it around changing risks. It is the timing of when studies are released because it can inform the public discussion that's going on around that extreme event. And that includes even when climate change is not a factor. And there could be other drivers that really drove that particular set of impacts. That's also important to be in the conversation. And then we see from more of an aspirational perspective, this ability to really have this information inform recovery afterwards. And that's something that we're starting to dive into a bit more now that we have a bit more resources, but I think there's a huge potential to be unlocked there as well. So very briefly, that's a bit about those two components of the attribution studies.